hello and welcome, and today we will discuss about from this book the complete guide to wiring. Basically, this will give you the complete overview if you are a beginner who want to start your career in electrical, so you can learn from the wiring. So house wiring is, or any kind of wiring, is very much important in electrics. So we will deep dig into this from this book about the wiring. So this all copyrights belong to this organization, so this video is for educational purposes, and all copyrights belongs to them. Quarto knows, actually they are the 2018 Quarto Publishing Group USA. They have this all copyrights. The content is the complete guide to wiring 7th editions, and this book is published in 2000. Follow the 2007 and 8, 17 to 20, 2017 to 20 electrical codes. Okay, so first is, let me, before introduce, let's go through the content. What is in the content? First is we need to know the basics. What are the basics? Like working safety with wirings. So how electricity work, you have to understand them. How the current flow, why current flow, and then glossary of electrical terms, basic terms, terminology, understanding electrical circuits, how circuits work, and grounding and polarizations. Home wiring, basics home wiring, and the wiring safety, what are the safety measures you have to take care. Then we will talk about the different kind of cable, type of cable, and pipes and conduit for, so wiring cables and NM cables, non-metallic cable, conduit, that pipes, we will talk about there all them. Also surface mounting wire, and then we will talk about the box panel, that wall box, electrical box, installation box, and electrical panel also. Then we will talk about the switches, different type of wall switches, type of wall switches, and special type of switches, and testing of switches. Then we will talk about the recapture, the type of receptacles and hospital wiring. So here GFCI receptacles and testing receptacles. So then we will talk about the preliminary link, preliminary work, planning your project, how you can start. So highlighting of the National Electric Code, because we follow some standards, so that is what National Electrical Codes need to be know. Wiring a home addition and wiring a kitchen. Then we will talk about the circuit maps, common house wiring circuit and their maps, common wiring projects like GFCI and AFCI, breakers, whole house sugar arrestor, uh, surge arrestor, service panel, grounding and bounding wiring system, and sub panels. Then 120 to 40 volt dryer receptacles to 120 to 40 volts range of receptacles, and ceiling lights. So basically this is because of India, American standards, so they followed 120 to 40, but in our case it's 230 440. And ceiling fan, ceiling lights, and recess ceiling lights, track lights, under under cabinet lights, vanity lights, low voltage cable lights, then hard wiring, smokes and co-alarms, landscape lights. Then we'll talk about the doorbell, programmable thermostat, wireless switches, and baseboard heaters, wall heaters, underflow radiant heat systems, then ceiling fan, remote control ceiling fan, retrofit, bathroom exhauster fan, range hoods, and backup power supply, installing transfer switches, then outbuildings, motion sensing and flood lights, standalone solar lighting systems. Then we talk about the repair project, then repairing light fixture, chandelier, ceiling fan, fluorescent light, plug and cords, and lamp sockets. So that is how we learn different kind of repairings also. So in introductions, let's talk about this this book. This is the newly updated 7th editions Black Decker, the complete guide of wiring, is the most comprehensive and current book on home wiring. So inside you will find accurate and detailed informations covering all of them, all of the home wiring solutions of the most of homeowners are likely to encounter in their home to repair and improve projects. So the informations within also confirmed for 2017 editions National Electrical Code, NEC, and typically most simple home wiring projects are unaffected by the changes of the NEC. So that is what here are the provisions most likely to after your wiring projects, so based on the new 2017 editions of NEC. So install AFCI protections the most circuits when remodeling and adding new circuits. So this is not a change in the 2017 NEC, but as more jurisdictions adopt more recent editions of the NEC, this requirement may be enforced more often. Number one. Number two is GFCI protections required for lighting in crawl space, garage, garage receptacles may not feed other outlets, and receptacles required in fixed cabin and bookcases. So we can start working safety with wiring. So first is, as it is in the as discussed in the content, first we'll talk about the working safety in wiring. So let's start it. So the only way you can possibly manage home wiring project safety is to understand how electricity works, as we are saying. So how it's delivered from the street to the outlet in your home, and the most essential quality of to appreciate about electricity is that the typical amount of flow through the wires in your home can be fatal if you contact it directly. Source estimate that here about 50,000 electrical fires. Source estimate like 50,000 electrical fires each year, causing 450 deaths and more than 1,500 injuries and 1.3 billion dollars in property damage. So home wiring can be very satisfying task for do it yourself, but if you don't know what you are doing, or are you are in any way of uncomfortable with the idea of working around electricity, so do not attempt it. This chapter explains the fundamental principles behind the electrical circuits that run through our home. So it also includes some basic tips for working safety with wirings, and it introduces you to the essential tools you will need for the job. So this the beginner should consider it mandatory reading. Even if you have a good grasp of electrical principles, take some time to review the materials. A refresh course is always useful. So in this chapter, what we will do, we will understand how electric work and glossary of electrical terms, and understanding electrical circuits, and grounding and polarizations, home wiring tools, and wiring safety. So basically how electric works. So here is the an analogy has been given. So this is water flow, right? Water flowing from top to bottom, and this is what actually in electric circuits happen. So our household electric systems can be compared with the home plumbing system. So electricity or electrical current flow in a where in much the same way that water flow, like that how our water system work. uh, so are distributed throughout the house, do their work and exit. So they come and go basically. So in plumbing, so they come in one pipe and they go in a different pipe, right. In the middle you use it. So in electric what happened, from the red wire, from the live wire or the hot wire, the electric current come that charge actually come, and it's used by the devices and then go back to the black wire, that is neutral. So in plumbing, water first flow through the pressurized water supply systems. In electric current, first flow along hot wire, that is red, and current flow along hot wire also is pressurized. Electrical pressure is called voltage. So the pressure, electrical pressure, is the voltage. Voltage is what it push the current to go from one direction. I mean from red and come back from right black. So this is what the voltage. So voltage kick the charge, uh, that molecule charge, uh, to pass through the conductor. But resistance is the one concept that is who try to stop it, but it will not stop because of the high pressure of the voltage. So large supply, okay, electrical pressure is called voltage. The large supply pipe can carry a great volume of water than small pipe. So likewise, a large electrical wire carry more current than a small wire. So this electricity carrying capacity of wire is called a ampacity. Ampacity. So water is made available for us through the fusive fivets, spigots, and shower heads in a home. Electricity is made available through receptacles, switches, and fixture. Water finally leave the home through a draining systems which is not pressurized. Similarly, electrical current flow back through a neutral wire. The current in a neutral wire is not pressurized at a 0 volt, and it is at a 0 volt, not pressurized, and is at a 0 volt. So here is that water system. So the main difference is that in on water and electrical, both the flow is that you can see water is flowing and can touch water, isn't like is not likely to kill you, but electrical likely, like electricity, water enter fixture under high pressures and exits under a no pressure. This is what that similarity analogy. So when everything is functioning as intended, do not assume however that the neutral is at 0 volt. Several defect can put voltage on the neutral, so treat the neutral as a hot wire until demonstrate otherwise. So here is the white neutral wire, here is the black hot wire. They use black hot wire. So color code will be different because of the different state or different country have different color code, but concept is same, right? So what you can see here, that hot wire coming and then switch is to control the volt and control, I mean flow, control of flow, and then it's enter into that fixture, light fixture, and then it's do its job, and then it's come back through white neutral wire. Now here is the delivery system, the electricity, how it's delivered to your home. First is it's coming from the power plants. So if I show you that how I can show you, it is online, right? Download is done. It's processing. Okay, so see here, notice here, this is our power plant. They are generating electricity by, yeah, like it is an, if it is a nuclear power plant and then use nuclear energy. If it is a, you know, if it is a coal power plant, like coal mining, that coal is used to burn water and then rotate the turbine and then it generate the electricity. So if it can be a solar electric plant, so there is different type of plant, we will talk later. And here is the substation. Substation is actually who control and regulate, like station, right? So we can't hold the current because this is a huge amount of current. We can only pass, we can only let it flow, and we can control its speed, right, by controlling its voltage or controlling its current or controlling its resistance. But we can't hold it, we can only control, like a train, we can only control it have to flow. So substation are located near the communities they are served. So but because of the speed, we need to control the speed. So because at home, whatever the power we are generating in a power plant, we can't use them directly at our home because this is the very fast electrical flow, you can say, like very high amount of voltage and current. So we can't use them that much power. We can use a very, so we need to step it down, step it up, in different phases it's happened, so we'll learn them also. So electricity, a typical substation take electricity from high voltage transmission wire and reduce it for distributions along street wire. So what substation do? Are located near the communities they serve. A typical substation take electricity from high voltage transmission wire and reduce it for distribution along street wire. Then we need electrical transformer. Transformer is the device that convert the electrical energy without converting its frequency. A static electrical device. So there is different kind of electrical device: active, passive, and statics. So here is that static device. So reduce the voltage electricity that flow through a wire along neighborhood street. A utility pole or a insulated pole, utility pole transformer or a ground transformer reduce voltage from 1000 10,000 or 11,000 kV volt to the normal 230 volts used in a household. So 110 120 is the in US, in 10,000 volts is in US, and India is 11,000 kilovolt. So parts of electrical system, different kind of parts I'll show you here. So the service mast or metal conduit. So here it is the metal conduit, you see. The weatherhead created the entire point for electricity into your home. The mast is supplied with three wires, two of which the insulated wire, each carry 120 volt, and 120 in our sense like 230, and originally at the nearest transformer. In some area electricity enters from the below ground as a lateral instead of overhead. So it can be come from on the underground or overhead, it's up to most of the cases in our India, like it is coming from the underground. The meter measure. So first, and then we have, so parts of electrical system. So first is our, from transformer to our this overhead or underground cable, and then we connect it to our energy meter. So this is the meter measure amount of electricity consumed by the usual, because you have to pay now, because we spend lots of money, government spending or organization spending them to generate electricity, and then they are selling it to the consumer. So consumer, we need to plug a energy meter, measurement meter, so that we can measure how much they are consuming. So according to that we can charge the amount of electricity consumed. It is usually attached to the side of the house and connect to the service master. The electrical meter belongs to your local power utility company. If you suspect the meter is not functioning properly, contact your power supply company. That is what most of the time is a government is regulating, or maybe a private organization. So surge is current flow. Surges in current flow to ground rods. This is the grounding actually they are doing, and there is the current flow back to the neutral at a service mast. Here is a light fixture, a grounding, earthing and grounding. We'll talk in deep and detail, uh, surely. The main service panel. This is our distribution panel. So if you see like this, here. Now I think it's visible. From here the current is coming, like basically no, it's this one is not there. So here coming, it's connected with energy meter, then distribution panel, then distribution panel to electrical boxes. What kind of electrical boxes is this? Check. Electrical box enclosed wire connections. This is our main service panel to sub service panel or distribution board, my control panel to distribution board, and then it's connect with the sockets and switches, and then to our light fixture, and also this neutral is in connected with the earth, and there is also earthing is there, and then it's go back the circuit black wire actually. So this is a closed circuit. So here what we learn we can discuss here, and here is one very much uh, total result, it's given. Let's try this. So glossary is ampere. Ampere is the nothing but the is the rate of at which electric current flow. Electric current actually in a where there is a charge, the positive charge that have a around in 1 second approx in a unit time 6.6265 into 10 to the power 19 coulomb, 19 pieces of charge, electric charge, positive charge flow in a unit area. So that is what the ampere is, this flowing rate. That refers to the rate at which electrical current flow at a light, tool or appliances, basically in a cable. So an armored cable is an assemble of insulated wire enclosed in a flexible net interlock metallic armor. So what is armor cable? An assemble of insulated wire. Basically, armor cable have a three core. If it's three core, it's a three one is its phase, one is neutral, and one other is earth. And it's four core RYB. It's mean three phase, one neutral. That is what. Right. So a device like box is box, cable, circuits. You know that, right? BX is a brand name. No need to know. Box. Yeah, we know box is the device used to contain wiring connections, and cable or two or more wires that are grouped together are protected by a covering shield, that is cable. And as we talk about the armor cable, is that with a interlock a metallic armor, right? Its cover is very you know good. And there is a circuit as a continuous loop of electrical current flowing along wire, that is called circuit. And circuit breakers, a safety device, MCB, RCCB, MCCB. There are many circuits breakers we will learn very soon. Then conductor is that metal that is in that insulated wire, inside the insulated wire. So any material that allow electrical current to flow allow through a copper through it. So basically conductor is like a metal, electric, copper or iron or whatever, they are the good conductors. But there is also semiconductor that is I mean in a certain cases it's good in conductor, but not every time. That is also semiconductor, that is the like diodes and transistors, they are semiconductors. Conduit, a metal or a plastic pipe used to protect wires. So form the conduits, like conduit is a pipe or the in water, how water flow, so through the pipes, right? That is this pipe is called nothing but a conduit. Continuity, an uninterrupted electrical pathway through a circuit or a electrical fixtures, that is continuity. That is an uninterrupted electrical pathway through an electrical circuit or fixture. Current, the flow of electricity along a conductor is the current, as I talk, and its unit is ampere. Duplex receptacles, the receptacles that provide connections of two plugs. Flexible meter conduit, FMC, flexible meter conduit, flexible metal conduit, that is FMC. And then is fuse. Fuse is actually safety device. If something current overflow, so fuse will burn. I mean they have some certain amount of capacity. Above that current will not flow or the fuse will burn. So the safety device usually found in older homes that interrupt electrical circuits during a overload of or short circuit. Greenfield, a brand. Ground wires, see the neutral wires. Grounding wires, hot wire is that, phase wire, insulator is that, I mean non-conductive materials, basically plastics and rubber. Junction box, box is that junction box, that is connection that have a connections of all, I mean so many conduits are coming into that box. Meter, energy meter that measure the power being used. Then voltage, we know voltage. Voltage wire connector voltage. What is the power? Basically voltage cross voltage in multiplication of voltage into current is the power. Okay, so VI, and also there is a three phase cos phi, and reactive power, active power, and there is a differences is there. So UL, we will talk about that power factor and all. UL is the abbreviation of underlying laboratories. Then switches, we know switches to control electricity flow. Short circuits, an ideal and accidental or improper contact between two current carrying wires, and between a current carrying wire and a grounding conductors. So service panel, a meter box usually near the site where electricity enter in the house. Screw terminal, a place where a wire connectors to replace switch or fixture. Romex replay power the work performed by the electrical or a period of time. Use the power marks, heat, motions, and light. Polarized receptacles. Pigital overload. Overload is the demand of or more current than the circuit wires or the electric wire was designed to carry. This should cause a fuse to blow and circuit breaker to trip. Basically, overload is have increase because sometimes the device increase its demand. That is because of some faults and damage. For that we have fuse or circuit breakers to save overload or short circuit. So the overload and short circuit are different, right? Sometimes it's shorted. So over outlet, a place where electricity is taken for use, is the outlet. Are right. So like common type of outlet, like receptacles is a common type of outlet. A box for a ceiling fan is another type of outlet. Non-metallic shaded cable, that is NM cable, nowadays is using more. NM cable is a consist of two or more insulated conductors, basically two. It's the two in the most cases a bare ground warehouse, a bare ground warehouse in a durable PVC causing casing. Durable PVC casing. Neutral wear, we all know neutral wear, no need to mention, that is the back path. The wire that return current 0 volt to the source of electric power, usually convert wire with a light gray insulation, also called a ground wire. But neutral or ground, very it's different. Let's understand this photo. I hope you will understand surely. So what is this? So we are talking about the electric safety and with wiring, right? Mhm. What is this? What is this? What is this? This is a wire thread prevent moistures. This wire threads, right? Weather heads, sorry, weather heads. This weather heads prevent moistures from entering the house, like if rain come and anything. So this weather heads help to protect. Will not enter the conduit. The water will not enter into the conduit. Basically nowadays we use ground, but okay, if you have weather coming from overhead, that's also okay. Prevent moisture from the entering the house. Service must create an anchor point for service wire, and service wire supply electricity to the house from the utility company's power line. So there is the utility from the, you see this power line, the service wire supply electricity to the house from the utility company's power line from the utility pole. This the service must create an anchor. Okay, now understand where this coming from. Now this enter the power supply enter into your house. Here is the energy meter. That is this energy meter is a actually the electric meter measure the amount of electricity consumed and display the measurement inside a glass dome. Okay, so to measure the electricity we use energy meter. After that this goes into your main panel. You see here is that coming inside the basement have the, actually we asked where to put, so owner tell us. So service panel distribute electrical power into circuit. So here is the service panel, distributors, electrical power into circuit. So here is the main circuit, main distributor. You said distribution panel, we call it. Now grounding wire to metal ground rod. So this is the grounding, earth ground. I mean this is yeah, they use the ground wire and they put it inside. Ground rod must be at least 8 feet long and is driven into the ground outside the house. So yes, earthing is been done, and this should be 8 feet. Uh-huh. Okay, from where this word earth coming? Yeah, this is the earth grounding. Now we receive. Now we have to distribute, right? Before we distribute, here you see this one is a separated 240 volt circuit of water heater. Here is the water heater actually. For water heater, so we are distributing to this water heater, this using a junction box, yeah, wall box here. Here is another device that is separated one. See, for that now we have to, because of why we are separating them, because we will use dedicated MCBs for security purposes to them. So yeah, and the cable type also will be different. Right, we'll learn very soon that what is inside this, how we design cover. So here is that separated, you see that what is separated: 240 volt circuits for water heater and 120 240 volt circuits for clothes dryer, because they are the heavy AC and geyser and lift and motor, all we need to give a separated connection, right? So this is what a separation. And here is the bounding wire to meter wire pipe. Okay, why? Okay, jumper wire is used to bypass the water meter and ensure any uninterruption boundary pathway. That's good. That is in the basement. Now let's come to this place. Here we have, now we are in the top of the building. You see the so many conduits and wires are go there. It's written that GFCI receptacles. Those are the box, that wall box. You can use them. They, if it is a kitchen, these are sockets actually. You can use to run your mixture machine or toaster, like many kitchen utilities we have now. Many kitchen devices, grinder or fridge, you can use them. So here is the separated 120 volt circuits for microwave oven. Yeah, we can use microwave oven or toaster or mixture, many things, many devices. High voltage, high power is needed for them. Voltage will be same, high power is needed basically. So wall switch, this is the wall switch for chandelier. Here is the switch loop we did, and there is the receptacles, another receptacles, right? So you can plug in many things for there. That's good, it sounds good. Understanding electrical circuits. Now here you see what is this, anatomy of a circuit. Here is the service panel that we are talking about, right? This is the service panel. We call it distribution panel or control panel, you can name it. Now here you see, here is the main circuit hot wire. This is hot wire is coming, and this is also, and here is the main circuit neutral wire. Actually it is defined, because if it is a single phase na, for single phase like 2 bhk we use single phase, for 3 bhk 4 bhk we use three phase. For three phase we have RYB, red, green and blue, red, yellow and blue. And for single phase we have only one hot red, and then it's black is neutral. But in this case we have a two main hot and one is neutral, main neutral, and they all are connected with the circuit breakers. Yeah, we need to connect it with the circuit breakers, and then circuit breaker to current controlling breakers, right? Current breakers, we can say. Circuit breaker is voltage circuit breaker. Nowadays we use module circuit breakers, and also residential current control circuit RCCB, residual cir current circuit breaker, RCCB. Yes, and yeah, I want to show you here. Okay, okay, okay. Okay, no, it's not working. There's another, no? This I want to connect it. So view two page, single page. It's a book view. Yeah. So now you will understand. Come on, come on, come on. View. Uh, No, I want it there. It was there, right? It's connected. No? Uh, Show bookmark, and also this is our 14 page, and view facing. Now we can see. See, now this circuit breaker here is the actually this is the neutral bar that has been connected, and this is connected with the with all, it will be connected with all the devices. So don't worry, this is the junction actually, or you can say looping. We do loop like this way, and here is the circuit breaker is supplying this neutral wire. I mean this hot wire, and it is also being junction here. We can use it parallelly, right? You can't connect it series, so we can distribute from there to different sockets. And grounding is already is there, ground wire, that we did. So in short, you can check. Uh, this also junction, this switch is connected, and this will connect it with the light switch. Okay, okay, I got it. Uh-huh. So here is the light connection. So basically you will go one by one single every time. So it's connected with the circuit. This circuit is connected with the socket. First we have to give hot wire, and another one is a neutral wire, right? So here we can bring the neutral wire here and connect, and then we also do loop, and we provide that into different circuit one by one. And we can control, we first give the hot wire a switch. Neutral, no need a switch, we can pass neutral, just pass it. So in this way we can connect it socket. So that is all for this video. In this video we understand the cabling, electrical circuits, and in the next video, after I charge my laptop, it's already drained battery. So next video we will talk about this grounding, polarizations, and different kind of wire, right? So what kind of wire we use, and what is their importance, and how wiring tools, like what are the tools we need, screwdrivers and cutting pliers and many others, insulation tape. So you will see them, hammer, nail, and multimeter, right? So we'll talk about them, different kind of interesting tools to understand, and different type of cables surely. It is yeah, and different way to connect and plug it, and how to measure it, and yes, see that internal diagrams how it look like, different way to connect conduits and doing insulations. Basically in India, what is all the wires is hidden in that wall, so you'll not find, but in here is for learning purposes we share. You see this conduits will be there, but don't worry, we'll learn different kind of box and panels and switches. Here is that uh, different kind of box, enclosure box, switch box, different kind of boxes there. Right, in India it will be some like something different, like this is the metal box. Now this kind of box we use, the junction box, and circuit breaker panel you see here. We will explain them to different kind of switches and fuse, circuit breakers, switches, then receptacles. This is also called jack or power socket. Receptacles, right? They see receptacles. Then we'll talk about the primary work, like how you can do the cross check is important, and circuit maps, how the circuits should map, circuit maps like layouts, different design. Nowadays we use AutoCAD to draw and design. We'll also give you the overview of how AutoCADs look like and how you can do drawings and all. So yeah, it is there. Then yeah, this is the repairing light fixtures, how you can repair them also, repairing light fixtures, and many way you can do. So that is all from in this video. In the next video we will surely talk more about. So thanks for listening, thanks for watching, and keep learning. Thank you.